Good afternoon, everyone. Next, you are going to hear a presentation from Professor Hanjie Zhao. Professor Zhao is currently a professor at the Department of Electrical Engineering, National Donghua University. And also, he is the president of Donghua University. Professor Zhao had been the president of National Yilan University and the director of the Computer Center for Ministry of Education in Taiwan. His research interests include IPv6, cross-layer design, cloud computing, IoT, and the 5G mobile networks. Today, he's going to give us a presentation entitled Application and Development of IoT in B5G. Ladies and gentlemen, let's welcome President Zhao.
Dear all the honorary guests and attendants either on site or through internet, it is my great pleasure through the kind invitation from Dr. Chen Huai-en to invite me here to deliver a talk for IEEE Censors Council Summer School.
So before I formally start my talk, let me briefly introduce about myself and the campus I'm now serving. I'm currently serving as the president of the National Donghua University, and I have been chosen to serve quite a lot of distinguished journal as an editor-in-chief or associate editor. And I have awarded several good awards, of course. For example, Survey Paper Award for Gold Survey Paper Award in 2020, Best Paper Award, and a lot of other things such as HCIS, Human Computing Intelligence Systems Award for 2017, and other things. And also I'm so honored to have the IEEE Network Premier Award in year 2014 and the IEEE Widely Censored System Premier Award for 2016. Where is my campus? Okay. My campus is located in the east side of the Taiwan, which is about 2.5 to 3 hour bus plus train distance. So it's not that far away from the international airport, and so I'm sincerely welcome all the attended for this conference after the COVID-19 outbreak. Well, you are all welcome to my campus, because the left down corner is a picture taken live on campus, which is showing that Donghua University is the most beautiful university in Taiwan. And we have a college. That means Donghua University is a very comprehensive university, of course. And Donghua is only 26 years old. However, we are ranking number 10 in Taiwan, which totally around 160 universities in Taiwan. And there are several other rankings from Times, provided from Times, such as Impact Ranking, we are number 5, Asia University Ranking, we are number 12, and Emerging Economic University Ranking, we are number 16, Young University Ranking, we are in the world 200 to 250. I guess the most important thing need to be mentioned is for subject ranking. In year 2020, for computer science, which I'm belonging to, is ranked as number 6 in Taiwan, and engineering and technology is ranking number 8 in Taiwan. But more than this, several weeks ago, 2021 subject ranking has been released. Our computer science has been moved one place up to number 5 in Taiwan. For a 26 years old young university, I guess we are doing not that bad. Some other rankings showing that Donghua University is keeping steady in certain range ranking. So we are not especially outstanding in only one ranking, but several rankings are almost the same, such as US News Asia QS ranking and the Run University ranking from Moscow. Here's a particular look of our campus, which has been newly finished building for the College of Arts. Okay, after some sort of self-advertisement, let me get back to my talk. Here's the outline of my talk, and I will skip several parts, or I will a little bit speedy on several part of my talk, because I guess most of you are quite familiar with part of my talk. So I just roughly bring you some ideas regarding the progress of what wireless communication currently have, but concentrate on the learning platform, deep learning platform for beyond 5G mobile network we had established 2 years ago. Okay, let's start it. Here's the wireless communication, and as we always know, we are limited using those spectrum. So whenever we need to upgrade from 3G to 4G, 4G to 5G, we have to squeeze the spectrum and try to find out particular range of those spectrum for particular use. That's the reason why for 5G, the vendor, service provider, or the vendor trying to move a little bit up to the millimeter wave, so that we can, in that particular range, can provide more spectrum for service provider to use. And what a coincidence, each generation, the separation for the time gap between each generation is about around 10 years. But I'm certainly quite sure for the 6G or beyond 5G, it should be less than 10 years, because I guess United States trying to push very hard to move to 6G as soon as possible. And of course, here are some from 1G to 3G to 4G. I guess for 4G, we are trying to connect everyone together, or should connect everyone into the internet. But for the 5G, we are trying to connect everything together. So besides the voice, message, internet, multimedia, there will be quite a lot of application regarding Internet of Things to be connected into the 5th generation. As predicted, we always know in year 2021, there will be more than 28 billion devices connected to the internet. Within it, only 13 billion belonging to mobile phone, PCs, those traditional mobile devices. However, the rest of the 15 billion will be all kind of different IoT devices, like a self-driving car, or robots, and even the solar cell it can be intelligent, connected to the internet. Quite a lot of important company has made up their mind made their own progress on 5G 5G trend, and also there's a so-called next generation mobile network group. They design a principle separated into radio for network and operation and management. So for each division or for each section, there are several topics need to be dealt with, such as for network, they are create common composable core, minimize the number of entity and functionality, things like that. Here are some next generation mobile network. They're trying to build up an ecosystem and guidance to E2E architecture and evaluation test and proof of concept result is also very important. Here are those companies and even the university who joined the NGMM group. And there is another group called IMT 2020 Promotion Group. It's a major challenge. They designed a major challenge for future IMT systems. You can take a good look. I guess we all come to a very unique or come to the same conclusion with the demanding for higher user experience data rate, of course, and zero latency as small as possible. And that means as small as possible and higher density of connection devices, higher traffic volume density, higher mobility, higher energy efficiency. All those factors are very important for 5G, and we are doing very hard to meet these demands. So for IMT 2020, of course, their technical performance requirement has a requirement based on the key capability, and there will be 5 additional requirements for peak spectral efficiency, reliability, bandwidth, things like that. So if we can really achieve what they require for IMT 2020, I guess for those 8 requirements, we can meet the requirement pretty well. However, for the 5th generation or for the user, there are all kind of different demanding, such as for the right up corner, for immersive 360, for those VR AR user, they are demanding throughput to be very high and high, but the latency is around 50 to 100 milliseconds, reliability is medium to high. However, if you are dealing with those industry robotic, the throughput is varied. Latency demanding to be much lower to 1 to 10 milliseconds. Reliability should be very high. So there are 3 different demanding, briefly divided into 3-4. One is ultra reliable low latency connection, and the second one, enhanced massive bandwidth mobile bandwidth requirement, and enhanced mobile machine type connection. These 3 different factors or 3 different sections briefly can cover all kind of users' demandings. Here are the 3GPP 5th generation going on. Currently, we are 3GPP in 2020, July 3rd, 2020, already released R16 being finished. That means 2020 in June 30, 5G for the first standardization protocol is ready by June 30th, and So therefore, all those vendors can start to deploy the 5th generation, follow those 3GPP protocols. And of course, next new radio needs some other technology besides LTE, because they are demanding those spectrum from 6 gigahertz as high as to 100 gigahertz. That means millimeter wave. So next radio will choose OFDM as their medium, connection medium. And several technology, of course, being bring forward, such as scalable OFDM-based air interface and the flexible bit-based framework. And in August 2016, 3GPP has agreed to using CP-OFDM as the 5G new radio uplink downlink waveform, the main waveform. So we have advanced channel coding, so they can be utilized for all different kind of frequency demanding or speed demanding, such as when you are broadcasting, or when you are a household, when you are in a household, or when you are driving a car in a high speed. So that's another is MIMO. Okay, MIMO you can using quite a lot of antenna to using beam focus, so you can effectively reduce the delay and using and low down the expense, of course. And you can using the mobile millimeter wave and beamforming, beam tracking enable wide millimeter wave bandwidth for extreme capacity and throughput, of course. Several functions have been introduced, such as authentic server function AUSF, and access and mobility management function AMF, and the data network DN, and structured data storage function UDSF, network exposure function NEF, network repository function NRF, network slice selection function NSSF, and the policy control function PCF, and so on and so forth. There are quite a lot of new functions being introduced. So that's based on the 3GPP TS23.501. It's the system structure, including those all those network functions. And based on the Release 16, we are using a 5G new radio and licensed spectrum will be using, along with licensed spectrum. So that that means we are trying to use every bit available spectrum. In the 4G 3GPP Release 12, formally define LTE-U to, that means LTE-unlicensed. And so for the 5G, is follow those Release 16 and being improvised or being enhanced in Release 14, and therefore we have bring those into so-called LAA technology. It will be even better than LTE-U. Release 16 has several features to improve the MIMO efficiency and functions, such as enhancing the multi-user MIMO to support higher ranks, and supporting multiple transmission and reception point, and better multi-beam management, improving reference signal to reduce peak to average power ratio, and extending uplink coverage, things like that. So in order to broaden our application, or such as being used in factory automation, with demanding the extra reliable, extra low latency, such as URLLC. For this kind of requirement, Release 16 also include the so-called supporting 99.9999% reliability upgrade, and at the same time trying to maintain millisecond latency. So trying to renew the E-URLLC can do something like that by using coordinate multi-point COMP communication and spatial diversity and channel polarization and those kind of technology being introduced. So the increased redundancy and more reliable, flexible scheduling can be expected. Since 5G is going to be using millimeter wave, of course, we are expected it will be even more power consuming than before. Therefore, power efficiency will be a very important issue here. Release 16 will bring in several power saving function features such as wake up signal, and so that your devices can beforehand know when to stop the transmission and when to go into the low power consumption mode or jump to the next discontinuous reception mode, so we can save the power, and at the same time those features are trying to also enhance the mobility handoff, so that you can predict your handoff function, so that when you're doing those handoffing or handover, you can reducing your interruption time, and by using those conditional handover or those report beforehand, and then for master cell group area coverage technology can be used as long as we are doing the handoff. And Release 16 also trying to expand the 5G network coverage, so and extended the public networking coverage supporting, and that's the another major feature of 5th generation. That means we are going to provide massive connection for Internet of Things. It's very, very useful when you are trying to deploy IoT. So Release 16 can also provide those time-sensitive networking to meet their requirements. In order to merge those time-sensitive networking stuff, we are going to do our best try and minimize those wireless connection, random radio access network, what their influence regarding those time-sensitive network or time-sensitive demanding. So therefore, we can have a time-determinist packet delivered. So also, Release 16 provide those new interference measurement technology. A very stable deployment will be established, and the base station to the end user devices interference will be mitigation, and time division duplexing will be even more easily achieved. And Release 16 also including some sort of 500 MHz unlicensed spectrum downlink using for and 100 MHz uplink upward using, that kind of a connection requirement, and that so before then this kind of connection has already been provided for vehicle to everything, okay, communication vehicle to everything for safety purpose. And Release 16 using those network new radio as a basic to provide coordinate driving and such as we can using the multicast communication and on the fly multicast group, and also at the same time distributed synchronization for QoS purpose. For those technology being introduced, new kind of feature can improve self-driving car, the safety and efficiency of the safe driving car. So here are the brief summary regarding what we are demands for 5th generation. I guess everyone should be very familiar with that already. And I have to mention that this paper has been cited more than 250 times. So if you are very interested on 5th generation, you should take a good look at this paper, the 10 key enabling technology for 5th generation. And multi-stream aggregation can be achieved through 3 different technology, like boosting sublayer, aggregate all the stream, and so that user end can obtain the most benefit from using this kind of boosting RAT and boosting port and boosting carrier stuff. And I guess mainland China already using the CRAN. I will skip this part. And for edge computing or fog radio access network is very demanding for the 5th generation, because we are trying to achieve low latency purpose. So there are some sort of introduction like this. When you're using normal speed, of course you are using the traditional connection through CRAN. But however, if you are in some particular position, you're using D2D mode, or maybe using some sort of coordination mode, relay mode, sorry, and then finally using the coordination mode, local distributed coordination mode. So here are the fog radio access network example. Of course, we are going to experience all kind of handover in 5th generation, or even in beyond 5G. Network slicing will be very, very important for 5G, because we're going to demanding flexibility and computing, heavy computing, and all that stuff, and also meet the requirement of the Industry 4.0. And flexibility is very important. So therefore, network slicing is very perfect choice for us to be chosen to provide it, to provide those kind of innovation. Based on the TS 2022.261, network slicing will allow the vendor to provide network connection to different kind of demands or requirements, such as priority, rating, policy control, safety, and mobility. And also there may be some difference between what you require, the function required, such as delay, mobility, capability, and reliability, and data rate. Or maybe for particular users, such as MPS user, public safety user, customer user, roaming user, or even the MVNO user. So network slicing can provide a whole network function, including wireless connection, and also provide all kind of network slicing, network slice. Because 5th generation going to use a high spectrum, so the coverage range will be smaller than 4G. Therefore, the base station, the total number of base station 5G will be much more than before. But in order to lower down the deployment expense, how to sharing the access network or doing the co-constructing will be a challenge. So several countries have been doing that. However, who to build it, who invest, who maintain it, who will take over those bills to provide service, it will be quite a lot of challenge for all those vendors to need to talk about. And this paper provides 5G communication, wireless communication, very typical environment, and massive mobile connection and ultra reliable low latency connection need to connect it to quite a lot of IoT devices, and massive machine type communication, and enhanced mobile broadband, and URLLC. You can see all different challenge. You can, if you are interested, you can take a good look at this paper, of course. 5G America, the white paper also point out that there are 3 different directions for home to home, home to machine, but I'm sorry, human to human, human to machine, machine to machine, different using. And there are several applications for 5G. One is using 5th generation onto agriculture, so that you can providing a more intelligent agriculture. For example, in our campus, we have a very close cooperation with a local farmer, because they are always fond of planting watermelon. However, it's really very tedious and very time consuming, and also manpower consuming to trying to figure out how many watermelon totally we have, because whenever you are trying to sell it, you should have a rough number totally how many watermelons. So therefore we are providing them using the UAV or the drone to fly up to the sky, and then using all sort of IoT stuff, or using those camera to take the picture and then calculate the total number of watermelon for the farmers, and make sure the error rate is within 5% or 3%, which the watermelon dealer will accept that kind of error rate. And this is a 5G tele-operated driving with Huawei.
5G is coming for a super connected world. The car industry is one of the first verticals to take advantage of cutting-edge 5G solution for improving road safety. Huawei is spending...
Of course, that's a 5G smart factory, 5G
as part of
UAV,
our research and standardization
and
in
5G
for
XR.
5G.
World's first drone. All different kind of 5G regarding healthcare and all those things, medical increase, being using quite a lot. Now I'm trying to bring you a rough idea for why we're going to move to 6G, because to be honest, 4G is quite enough. Okay, we can take a look of high resolution film such as 4K easily using 4G already, and almost we can connect to everyone, everywhere, anytime. However, we all still demanding for sixth generation what really want, because when those AR, VR, virtual reality, augmented reality, and intelligent self-driving car are so popular, therefore quite a lot of data transmission and storage being generated. For example, for medical purpose, almost every person, if you put some wearable devices and maybe implant some intelligent devices into your body, for each individual, every second you can provide 1 terabyte up to 10 gigabit per second, 1 terabyte static and 10 gigabit per second dynamic information. If under the emergent circumstance, it will also demanding high-speed moving and on-time live transition, on-time interconnection with the hospital, and I guess 5G is still a little bit difficult to meet this requirement. And at the same time, the spectrum is limited. So how should we squeeze even more spectrum, or using MIMO and millimeter wave to solve the spectrum problem? However, as we always know, using millimeter wave, the coverage range will be shortened than before, and so that intelligent spectrum sharing, co-constructing, as I mentioned before, will be become necessary. And at the same time, from 1G to 4G, we are always using the cellular networking. Therefore, the reason, one of the main reasons, is that we may increase spectrum usage efficiency, and therefore your capacity will be also increased. However, using the cell phone structure and also complicate the spectrum management and complicate the end user get into the mobile system, and at the same time how to deal with that, because it will certainly block your improvement or development for 5th generation. So maybe in the future, supercell will be the key core idea for the 6th generation. There's several supercell. You can take a good look, and using Google, you can take a good look to see what's going on in the future. And based on the ITU-D, 5G enable industry demanding even more vertical application usage, such as intelligent IoT, or maybe even AIoT in the future. So at this time, although we are already demanding as a low latency, as low as possible, into 1 millisecond to 10 milliseconds. However, in the future or at this time, some sort of specific requirement even demanding peer-to-peer latency to as low as 0.1 millisecond, and also even lower to 0.02 millisecond, which really will bring a lot of challenge to 5G, and that's what 6G is going to deal with. Another reason is that currently our wireless communication only cover 70% of the population on Earth and 20% of the land area, but you cannot ignore that there are still 80% land area and 95% ocean area without any signal coverage. Therefore, integrated space terrestrial satellite communication and the satellite Internet of Things must be introduced to solve this problem. And how to compatible with these two technology will be a very big challenge, because in the space and also trying to solve underwater communication, there will be quite a lot of technology challenge on that. For example, the figure on the top, the left-hand side is an integrated space terrestrial satellite communication structure, and the satellite can be divided, can be grouped like a LEO, MEO, GEO. And the right-hand side, when you're using drone assisted cellular network, and using that, combining with those satellite communication in order to increase your coverage area. And mobile cellular network today covers only 60%, as I just mentioned, and so we have to try to cover. But one of the good news is the founder of the Tesla, Musk, just released that SpaceX can provide downlink regarding approximately 140 megabit per second, which is very, very fast, those kind of satellite communication compared to satellite communication. And in the future, SpaceX and Amazon are going to launch quite a lot of low orbit satellite and trying to achieve the so-called everything together, X on internet, XOT. However, there will be still a lot of challenge for beyond 5G and 6G, like security problem and contradiction between complexity and reliability, the relationship between artificial intelligence, which is very hard now, and those are between artificial intelligence and 6G development. Now, development IoT, I will go through it very quick. Okay, the first IoT have been introduced in year 1974. What's that? It's a ATM machine, right? In 2015, already those kind of devices being increased 233%, and we are expecting in the end of this year will be even more than 250,000 devices being introduced. So quite a lot of IoT devices will be implemented, such as a water meter, electricity meter, gas meters, things like that. So in order for that kind of purpose, one of the 5G fifth generation user case is a massive device connection. Currently 4G is not able to do that. So IoT devices will be using light spectrum and unlicensed spectrum, or even the LoRa unlicensed spectrum to solve the IoT devices problem. Make sure 3GPP can move into this market. And currently, for fourth generation, LoRa has there are two main technologies for IoT connection, LoRa and BIoT. I guess LoRa is basically for application purpose, and BIoT is for coverage purpose. So LoRa using a licensed band, and BIoT using a licensed band, and supporting by all those service providers, traditional service providers. So I guess NB-IoT will dominate the market sooner or later. If you're demanding more bandwidth, then you can still using the enhanced message type communication to provide you even more bandwidth than NB-IoT. here are the example by merging the IoT and the fifth generation devices will be the IoT application, including smart city, industry 4.0, and using LoRa and BIoT can be connected to the internet. And there will be a lot of platform and infrastructure to collect those information gathered by those IoT. And through this platform, we can develop all kind of application, all kind of service to our users. And smart city, I guess everyone should be very familiar with that. I will skip that too. And smart healthcare, I guess health plus big data platform with help of the artificial intelligence. A lot of people may get jobless in the future because they are considering a lawyer, doctor, can be replaced by those artificial intelligence. And of course, there are a lot of Internet of Things challenge for Internet of Things. Security and privacy will be things like that. As long as you put so many intelligent devices around you, your privacy and security will easily be revealed. For example, you're using Google Map. Every month, Google Map will provide you your pass for the whole month, your road pass, driving pass in the whole month, where you're driving from where to where, which city you've been staying, and things like that. Once this kind of information being released, then everyone know where are you going, where you were going, and where you have been staying. That's the problem of the modern world, of course. And beside that, quite a lot of unit being installed. Those internets. Gartner predict that IoT devices will be, as I mentioned before, will be to 26 billion. And so along with those billions of devices, quite a lot of garbage information being gathered. Now we're using cloud to lower down the cost. However, if you put everything on the cloud, you will lower down your efficiency for sure. Therefore, Cisco has provided so-called fog computing, and there's what is fog? Fog computing is something like edge computing. However, the only small difference between fog computing and edge computing is that fog computing trying to push edge computing try to push computing and storage as to the user end as possible, but fog computing will somehow in between. So that's what deep learning can kick in to play an important role when to decide it, which part should be put in the cloud, which part should be put in the fog. And here is an example when you're using fog computing. If you're in a stadium, you miss the important shot when the player shooting the ball. However, you want to replay those important moments, and within the stadium there will be maybe 1,000 people demanding to replay those important moments. And fog computing can easily solve the problem. And when you're using fog computing, you can lower down your loading, and when you're using virtual reality because virtual reality need quite a lot of image recognition. Those image recognition will be stored in the cloud, and of course it will delay your augmented recognition. So if you combining augmented recognition and the fog computing together, and of course you will decrease the delay. I guess self-driving car is another important application for computing. So challenge for computing is like as before. One I mentioned only several of it, edge caching. The first is edge caching. What's edge caching? That means how big your fog should be. If you put your fog to be as big as cloud, then what do you need a fog for? And there are also discovery synchronization, centralized points, and standardization issues. Quite a lot of standardization issues. And development of AI, because my time is quite going to run out. So I guess all the people should be quite aware of the deep learning nowadays, divided to be 3 different important algorithms: supervised learning, unsupervised learning, and things like that. I guess this should be very important because it combine all different topic for network in mapping to some specific deep learning method, such as access point selection. It will be considered as a supervised learning. D2D communication will be considered as a unsupervised learning, things like that. And also, there are quite a lot of different algorithms belonging to 3 different learning stuff. You can take a good look. Okay, here is the deep learning platform we've been built for the past 3 years. And the first year we are trying to deployment of deep learning platform, and the second year we implement all kinds of network function I mentioned in the early of this speech. And finally, for this year, we're trying to finalize to provide a self-organization deep learning platform. As you can take a good look, when we deploy the deep learning platform, we separate into the B5G access layer. This layer we've been built already, and then we're trying to build the core network layer, because the B5G access layer belong to the first 3 years, 7 years ago, the project 7 years ago. So, and then recently, we are going to, or 2 years ago, starting from 2 years ago, we're trying to install the core network layer and deep learning service centers. As you can see, this is the process of deep learning platform. It divided into data processing platform and data training platform. Data pre-processing platform. The main function for data pre-processing platform is trying to to analyze the data and trying to set up the model. Data training platform is trying to do the deep learning calculation, and so information will be goes through the edge server to do the data pre-processing, and this kind of edge server can be co-located with the base station, so that can provide because base station can provide limited computing resources, such as you're using your cell phone, notebook, PDA, things like that. And through those for computing technology or function, so we can avoid all the information coming from or going to the cloud. You will use up quite a lot of your traffic. And after those pre-processing, this information will be uploaded to the cloud server. Cloud server will depend on different kind of network requirement, using different kind of deep learning method to do the model training. After the training, model will be sent back to the base station, prepared to be used in the future. And so the second stage is trying to data training platforms and data pre-processing platform is 2 independent platforms. And in order to make them to be do those automatic deep learning process, we have to couple these 2 platforms together. And so after beyond 5G platform can use those models directly, and how to make sure they to be local maximized, and how to increase the deep learning efficiency. So we are also how to improve those work functions such as fault management and traffic classification for security and core network and mobility management and edge computing, hotspot management, things like that will be these functions can be using to enhance your deep learning process. For the third year, we're trying to make sure our deep learning efficiency to be as good as possible. So our deep learning platform using GPU, TPU to do the load balancing, and also there will be network access management and collecting all those data, big data, and trying to analyze it, and providing security management and core network management and edge computing management and mobility management and interference between base station, also trying to make the whole thing to be even better than before. Here are the self-organizing deep learning platform and providing all those network function as I mentioned. And here are the platform we've been built. Okay, according to the network structure, we have a CRAN and using user N, using a SIM card, and station using a Huawei use cell phone. And because we are using the so-called physical administration function, we can easily change the registration information on the SIM card. So whenever E-NO-B connected with the evolved packet call, they will automatically get into the home subscriber and trying to see whether there's the information is correct or not. If they cannot find the SIM information, we will reject the connection. And here are some integrate edge computing and cloud computing together, and you can see that easily see that. And here are several examples. We have actually built those CRAN, E-NO-B, and evolved packet core. And these are those pictures regarding all those stuff. Live picture we've been built. And here are some particular example. When using Wireshark, you can take a good look of MME, the communication between MME and the E-NO-B, and OAI, and all kind of signal message. You can take a good look of that. So and OAI will gather those radio frequency like a receive signal and channel frequency response, and the so-called physical uplink control channel and physical uplink share channel. Those information will be recorded, and by looking at those information and those you can take a good look of signal strength, and the so-called channel quality indication to see the signal quality, and therefore base station can allocate the resource block, the better resource block, so you can get a better transmission efficiency. Here are the example. We are using YouTube and the speed test to see what our platform been doing, and you can see that after we playing the tape, the maximum downlink will be 32.5 megabit per second, uplink will 4 megabit per second. However, and if you are demanding a lower connection speed, will be 0.5 megabit per second. Apparently, end user devices will be influenced by OAI parameters such as transmission, receiving gain, and reference signal power, permutable initial received target power. And so therefore, we gather all those information and put it back to our deep learning input information and trying to train a model that in the future we can provide appropriate resource to the appropriate demand or requirement. And we're using mobile NetBeast version 3 CNN lightweight model to predict the network connection. We are a little bit better than convolution LSTM, but the training time and parameter have been reduced quite a lot. This is the throughput of 2 different base stations. And roughly speaking, we can predict the traffic change. And for our subproject 2, we are developing deep learning-based security fuzzy testing functions or testing tools. Through this, through this figure, you can easily see that after we're connecting several different end user devices such as Qualcomm, Snapdragon 630, 800, 810, 820, 835, and Intel and Qualcomm, since that, the result shows that the proposed system can generate and cover more than 90% of protocol of beyond 5G mobile connection access network into it. That's quite a acceptable result we can have. And by collecting all different kind of payload through the deep learning to distinguish the user service into such as NB-IoT or UAV or 4K videos or even Facebook. So then later on, we're using CNN-based method to divide the packet and try to test the different payload size. And you can see that the accuracy is pretty high. And combining with the edge computing with IoT and AI, and putting your AI model into those edge servers, we can provide some sort of real-time services, such as left-hand side is our subproject 4 system structure. It's being divided into 3 layers. The first layer which should be IoT devices. The second layer is MEC. The third layer is cloud. So we're using MQTT broker because all kind of different edge devices may using different protocol. So MQTT broker can easily communicate with different IoT devices, and so that IoT devices and edge server communication can be easily achieved. As you can see from this diagram. And interference between base stations is quite important for beyond 5G or 5G beyond 5G. So building interference into terrain interference and large obstacle interference by using CNN model to do the base station deployment. Try to avoid those interference beforehand. Okay, Here's my conclusion. The edge computing is very important for even 5G and beyond 5G. And different network users have appropriate deep learning algorithm. Integrated edge computing and cloud computing is expected to provide greater performance efficiency for beyond 5G platform. And there are many applications can be implemented on beyond 5G platform, which based on edge computing and AI, such as security management, interference management, access point selection, mobility management, and so on and so forth. Okay, then there's about all I'm going to talk, and 5 minutes about my time. And again, Donghua University is only 26 years old, but we are standing firm and trying to make sure our campus is to be globalization. And thanks for listening, and hopefully I can see you all on campus, or even better, I can see you in the world in a couple months. After a couple months, the pandemic is really hurting us. I've been house arrest or been grounded for exactly 1 year till December 30th. So I'm looking forward to seeing you all in the world soon. Thank you so much. Bye now.
Good. Next, you will be hearing a presentation from Professor Nenfu Huang. Professor Huang has received several outstanding teaching awards from National Tsinghua University. He's also the founder of ShareCourse, an AI-based MOOCs platform, which provides MOOC courses. Today, he's going to give us a presentation entitled AIoT-based Agriculture Blockchain Service Platform. Ladies and gentlemen, let's welcome Professor Huang.
嗨，大家好，我是清华大学电机资讯学院黄仁富黄院长。那今天很高兴有机会来跟各位介绍我们这几年在 AIoT 的智慧农业，以及怎么样把 AI、IoT 跟区块链用在智慧农业提供一个服务。So last year I visited Manila and I visited a supermarket, see the dragon fruit, and I'm wondering where is the farm, how they are planted, and are these dragon fruits organic certification or a GCAP, and how is the quality label, and how they are delivered to here. I mean the cold chain, the logistic. And I'm wondering if I can have a QR code on the skin of the dragon fruit. So in Taiwan, we are also working with many farms, and including the dragon fruit. So we put a blockchain-based QR code on the dragon fruit to provide fully trusted traceback service. And also for this pomelo, we also provide a blockchain QR code on the pomelo to provide a trustworthy traceback service. These two. And in the experience that we put many sensors in the farm, include outdoor farms or indoor greenhouse for the organic vegetables. We put many sensors in the farms, and through the LoRa or NB-IoT, we collect the data from farms, put the data in the cloud platform, and then we analyze the data with AI technologies, and also cooperate with experts, for example the farmers, and also consider the biotech, and when we decide, we'll analyze how the data stands for the farms, and we can also remote control for the irrigation, fertilization, or even lighting or fan, such that the farms can be more suitable for the crops to grow up. And during all these steps, all the actions, all the data are collected and stored in the blockchain service platform to provide the traceback. Now you can see that in the agriculture blockchain architecture, in the left-hand side, where are the farms, we put IoT sensors and automatic systems in the farm, and also we check the examination. For example, organic or pesticided residues, and we use AI technology to classification the crops, the fruits, and also we use cold chain to deliver the products to the restaurant, to the supermarkets, and also to the consumers. When consumers receive the fruits, the vegetables, the products, there is a blockchain QR code on the products, so the consumer, the user, can scan the QR code. Then we can understand the traceability from the logistic, the classification, the grade of the quality of the products, and also the examination certificates, and also how the products, the crops are planted in the farms. And all these data are provided and and set in the blockchain service platform. In the past 6 years, we have built many smart farms in Taiwan, including smart paddy, and also greenhouse, organic greenhouse, banana, dragon fruit, or even coffee and grapefruit. So we built many systems in Taiwan with AI, with AIoT. So the first one, we have to collect the stations, the weather from the field. So we developed LoRa or NB-IoT based weather stations. We know that the LoRaWAN or NB-IoT is long distance wireless communication technology with a distance about 2 to 10 kilometers. And our weather stations also provide a solar panel to provide the power, and also provide the air, sensor temperature, humidity, light sensor or rain gauge, and also wind speed, wind directions. And also we provide ICE 485 standard interface for more sensors in the future. And also for the soil, we also provide the LoRa or NB-IoT sensor hub to collect the soil temperature, humidity, or EC value. Also, we provide even more light for the soil sensor with the temperature, humidity, and the EC value with LoRa and the NB-IoT transmission technology. We know that LoRaWAN or NB-IoT or long distance wireless communications, which can deliver to around 10 to 20 kilometers. This is our soil sensor to collect the pH, soil pH value. And this is more even important to collect the soil NPK value, also provides LoRa and the NB-IoT sensors. This is our LoRaWAN sensor hub and the LoRa base station installed in a dragon fruit farm at the Pingdong, the south of. We know that for the paddy field, the irrigation management is very important. For example, generally there are 4 stages for the rice growing. The first one is the seedling stage, and the land is the vegetative growth stage, and the land is reproductive growth, and then maturity, and then harvest. We know that for the different stages, the water level control is very important. Actually, for the whole cycle of the rice growing, there are 15 different levels for the water levels. So how to control the water level is very important for the paddy fields irrigation. And for the automatic video capturing and analyzing systems, we built many high-resolution video camera in the paddy fields. Actually, we try to analyze the objects in the picture, such as the spider web. We know that spider web is very healthy for the paddy. So in Taiwan, the farmers would like to have more spider web as possible. And also we can very clear recognize the fortune snail in the paddy field. You can see that our camera can take very clear image from the paddy field. Or even in the night, we can also see very clear rice and fortune snails in the paddy field, and even for the fortune snail eggs. Then we try to monitor the whole cycle of the paddy of the rising from the seedling starts. So we use the image processing technology to identify each rice. So from the seedling, we can recognize, for example, the height and the width over each rice. From the different periods, we can recognize and calculate. And this technology is very helpful for the farmers to understand the growing situation for the paddy field. You can see that we learn more and more image. We can recognize the whole the shape of the rice. You can see here, 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 and here, and here. So we can analyze the rice automatically from our AI model. So currently, we have several smart paddy stories in Taiwan, including the north of Taiwan, which is 5 acres, and the east of Taiwan is 100 acres, and also in the middle of Taiwan, which is about 200 acres. For the north of Taiwan, in Taiwan, most of the paddy field is out of electricity support. So we need to provide automatic irrigation by the panel, the power. So we have automatic control water gates in the paddy fields. And in the north of Taiwan, we use a LoRa technology to transmit the data. Yeah, you can see the smart paddy farm, including the 5 fields. And we install the automatic water control, some soil sensors, and also weather stations, and the speed dome for the video streaming systems. This is the original picture of the paddy field. And the traditional, the farmer use a pipe to control the water. And we install weather stations, soil sensors, and also install solar power stations, which can provide the power for the automatic control, and also we provide the manual control. And you can see that the solar power stations can support the power for the automatic water gates, and also for the speed dome, the video image control systems. I will show a video to show how the water control gate works. You can see that the gate is closing right now, and I will feedback to open the water gate. So we can use remote control to control the water gate. For example, I show another video to show how it works. Yeah, you can see that when we open the water gate, the water is flowing into the paddy field. Okay, and for the east of Taiwan, we cooperate with a farmer with 100 acres. Also, we install weather stations, solar panel, power stations, sensor hub for the soil sensors, and also for the automatic water gates in the paddy fields. And in the middle of Taiwan, we cooperate with a farmer which has about 200 acres. And currently, we install the weather stations and the soil sensor in 20 contract farmers, 20 paddy fields. One and to store all the collected data, we also design a cloud-based IoT data analysis platform, which is located in the web cloud service such as Amazon or Google. The IoT data analysis platform will collect many data from the farms, including the light intensity, the soil temperature, humidity, EC value, pH value, and NPK value. And also we can compare the data for two different types of sensors. For example, the soil humidity and the EC value. What is the relation between these two sensors data? So our platform can analyze for different sensors, and also can compare the data for the same sensors with different locations. So we can provide all these data analyzing service to the farmers. So we can display and analyze all the IoT data from the farms for the short-term or long-term comparison of the data. We also provide a farm management app for the farmers, including Android and iOS platform. So the farmers can manage their farms very easily through the apps, the farm management apps. The farmers can watch all the data via the apps. I would like to share one of our example, which is a dragon fruit farm at Pingdong, which is located in the south of Taiwan. This farm has 11 acres, which is the largest single dragon fruit farm in Taiwan. And there are totally 4,000 acres dragon fruit farm in Taiwan. But there are different types. The most of the dragon fruits we call the big red. And in our corporate farms, the type is we call the sweet baby, and the pollination is by workers. And also we change the harvest time from summer to winter. This is the most important by using the lighting. And also the harvest twice every month, and its harvest they are 30,000 kilo, and for the years is 300 kilogram. So it is very successful fruit dragon farm in Taiwan. You can see the dragon fruit flowers is very beautiful, and also it's very huge, very beautiful. You can see in the background there are many lights and LED lighting in the farm. This is the boss, Mr. Liu of the farm, and this is me. And we also work in the night to make the dragon fruits more beautiful. It's very beautiful and delicious dragon fruits. very huge. Yeah, we have a sensor hub and the LoRa base stations, and we change the harvest time from summer to winter by the lighting. I'll show a video. You can see that the farm is very beautiful in the night, and there are around 30,000 LED in this farm. In the night, it's very beautiful in Taiwan. We can also another video which was taken by a drone fly back over the farm in the night. You can see that the farm is very beautiful, and under the LED light, the dragon fruits grows very well, and we control the flower of the dragon fruit by the lighting, so that we can change the harvest time from summer to winter. So when the dragon fruits are mature, we have to harvest. So we have another technology we call crop classification, and by the AI and by the machine learning. Traditional in Taiwan, for the past 20 or 30 years, the farmers classify the grades only by the weight. We can see there is a machine, and also the dragon fruits are put in on the machine on the delivery bands, and this traditional classification is only by the weight. But we believe that the weight is not only an important factor to classify the fruits. So we try to use machine learning. So we take many pictures of the dragon fruits to labeling, and also to try to classify by the image of the dragon fruits. And so we design, put some AI technology in the traditional machine, so that we can not only classify by the weight, but also we use the machine learning to check the image, the surface of the dragon fruits, so that we can identify more precisely with AI machine learning technology. 穿戴式本身它还有一个东西就是这个 G sensor 就是可以震动。那震动感应器本身主要是在像工人他在这个工作里面他移动他在走路啦，他在工作啦那他的这个整个动作有震动的，我们都可以把它做这个感测，然后传输，然后加上卫星定位然后做路线的追踪管理那这个部分呢，我们也发展了一个 IoT 的这个数据分析的平台，也就是说在这个农场啦，或者在校园或者在一般的都市里面我们常用的这种sensor那我们这里强调是像 LoRa 或者 NB-IoT， 因为他们都是长距离低功耗的这种通讯嘛那不管是固定的 sensor 或者移动的 sensor不管是震动的感知或者卫星定位然后它的路线的追踪等等那 LoRa 的话，我们就直接因为 LoRa 基地台必须自己建置嘛所以透过 LoRa 基地台，我们就可以把数据送到我们的云端平台。那如果透过 NB-IoT那就是看我们 NB-IoT 的那个 SIM 卡是用哪一个电信公司的因为 NB-IoT 的传输必须透过电信公司的 NB-IoT 的基地台。那透过这个 operator 或 telecom 的 operator 那一样它可以把数据呢一样转到我们这个 IoT 平台来。然后在这个平台上面，我们提供这个 API， 也就是说我们可以再透过这个 API 到这个平台去把你的数据再把它拿回去等于说每一个人每一个应用 比如说人的追踪啦、农机具的追踪啦、环境的管理啦然后设备的管理啦等等，交通等等都可以到这个平台来，把自己的这个 data 带回去，然后你就可以自己做更多的应用的分析那刚刚有提到像这个农场11公顷很大，那我们在这个农场的中间这里架了一个 LoRaWAN 的基地台。那因为 LoRaWAN 的基地台，它的通讯距离通常都是好几公里甚至可以到十几公里所以这个整个农场的面积都是可以被覆盖的好，那因为我们这个农场很大有很多工作要做比如说我们要去疏花我们要授粉，我们要施肥当然现在施肥是靠那个施肥车了那我们要采收就是收成然后要除草这个除草也是靠车子有的靠人有的靠车子所以这个这些工人然后这些农机具本身它到底已经比如说已经在哪里工作了这个对一个大型农场来讲如果没有很好的管理工具的话这个效率上、成本上还有整个这个管理上都会非常的困难所以我们可以透过人农机具的卫星定位，然后透过 LoRa 的传输可以知道说这个工作本身就像疏发、授粉、施肥，然后除藻、收成它的完成的区域啦完成的比例啦整个工作的效率啦那甚至这个工人本身的安全性也都给他考虑到，因为我们那个穿戴式的装置可以感知它有震动所以我们也可以感知它没有震动，也就是万一工人在这个白天太阳很热做这个采果的这个工作的时候，或者疏花的工作的时候呢，假设啦万一发生的这种我们叫热衰竭晕倒，那他就会倒在地上，然后当然就不会动嘛我们也可以立刻感知立刻回报所以不只提升这个整个工作的效率而且增加这个整个工作环境的安全所以像这个例子就是说，在这个农场我们这个工人他在这个周边等于说在巡这个农田的时候，我们就可以用卫星定位可以知道它的路线这个每一个位置的这个标志上面都有编号所以我们都可以知道它的路线跟前后的这个路径那像这个就可以看到说这个工人或这个农机具它在中间这个每一块都是5分地所以在这个上面它的工作的这个路线图都可以很清楚的看得出来。所以我觉得说对于稍微比较大一点的农场我们的工人的管理农机具的这个整个工作的管理那尤其将来我们讲如果整场输出到海外在海外面积更大，农场更大那我们怎么做远端的管理因为这些都透过云端数据，所以我们在任何一个地方我们都可以做远端大型农场的这个管理。And for the organic greenhouse, we know that for the organic greenhouse 人工了也就是说可能靠人工像这边这个就是一般的人工的这种浇水的把手嘛也就是说每天假设你有很多棚，这个农民早上到这个农场大概每天都要用手去在这个地方就开关嘛，然后因为每一棚种植的作物不同，而且种植的这个应该说阶段也不同，有的是刚刚种有的可能种到一半有的快要采收了那因为在不同阶段的这个农作物或者不同的农作物，它所需要的这个水是不一样的所以农民本身当然每天就要记得这些细节，然后每天都要浇水，每天都要去浇水那如果这个棚很多的话那这个当然就会花很多时间所以我们就帮这个温室有机蔬菜然后设计了一个用 LoRa P2P 的这个 protocol 设计了一套全自动的浇水系统。那这个浇水系统是根据你的环境比如说日照就是太阳的大小，然后根据土壤的温度湿度甚至电导度 等等，就是说根据环境的这个 data， 就是说我们会把这个环境的 data 都收集起来，放到云端去，然后经过分析之后呢，然后帮每一棚计算每一棚应该浇多少水是比较合适的啊。然后经过这个农民的同意或者经过我们给他的 APP 上面有这个浇水的这个排程等于说我们会用 AI 自动帮他算每一棚要浇多少水当然农民本身还是可以用他的经验去做调整比如说增加一些时间或者减少一些时间等等那透过他手上的这个 APP 的 scheduling 就是排程呢然后按一键启动之后我们就透过 LoRa P2P 的 protocol 就去控制这个浇水阀那在浇水的同时我们也有水表那也是 LoRa P2P 的水表 LoRa P2P 的浇水控制器就是水阀然后可以帮它做全自动的浇水。那这样的话可以大量的第一个节省人工浇水的成本，那第二个也节省避免人工浇水造成的一些失误啦因为人工有可能比如说忘了浇或者浇过度或者浇不够因为都是靠人工去计算嘛那现在全部把它导入这个全自动那也透过 AI做这个浇水这个 modeling， 然后透过这个 modeling 本身，那透过这个 app 的一个浇水的排程我们也可以帮他做这个全自动的浇水那像这个就是我们在新埔就是新竹县新埔一个有机农场，那实际建制的这个是收集土壤这是土壤的感应器就温度、湿度、电导度然后 LoRa P2P 的 Sensor Hub 它会把它的这些土壤的数据还有光照度的数据呢送到我们的这个LoRa P2P 的这个 Master， 然后 Master 根据这个model 呢然后来分析说那应该要浇多少水会比较合适，然后把这个浇水的建议呢给这个农民看，那农民如果同意呢他就按下那个我们叫一键开关按了之后在手机的 App 上面我们就会自动帮它控制这个水阀的开关，自动浇水。那浇水的同时呢我们也有一个水表可以去记录它浇了多少水那这个是农场也常常会有相关的这个农民团体去那边参观交流。好，那这个弹性的这种自动浇水的机制就包含说我们可以用时间设定时间什么时候要浇，或者用manual 就是农民自己去手动去开关那也可以设定相关的规则比如说土壤的这个湿度小于 50%或者空气的这个温度大于32度 C 等等来自动浇水当然我们刚刚有提到我们主要还是希望慢慢就导入这个 AI 的 machine learning 的 algorithm 就是预测建议这个每一个温室到底要浇多少水是最好的好，然后来自动帮它浇水。我想这样的Solar AI based automatic irrigation systems, we use AI machine learning algorithm to automatically learn the farmer's irrigation experience. And this is a cost-effective, high efficient, and also accurate, and save manpower, and also save time. And we're analyzing data based on the air sensors, soil sensors, water sensors, or weather stations, and collect from the greenhouses. And our AI algorithm predict and suggest the best amount of water for each greenhouse. And the farmer can use the app to adjust the amount of water if necessary, and then push the start button on the app to start the whole irrigation. And also we built a farm management war room, which is monitor room for the farmers. With, for example, this one with the TV, so the farmers can watch all the data in the war room, and then she can control all the necessary actions for the fields. For example, the farmers can use our APP to control the auto irrigation. and also to even contact with the contract farmers to do some necessary processes 精准哈。那像这个就是在刚刚提到那个有机蔬菜这个大坪窝这个农场，那它的有机蔬菜采收之后呢我们会提供一个 QR code 的贴纸。那这个 QR code 的贴纸呢就是说它是有区块链信赖溯源的这个 QR code， 也就是我们扫了这个 QR code 之后呢，就可以看到说这个农场的介绍，然后它整个种植的这个数据包含它的施肥的管理、灌溉的管理然后从这个农场把这个蔬菜送到客户这边来它的物流就是它的路线、它的GPS 的定位，然后花了多少时间，然后在运输的过程当中它的温度湿度的控制如何，因为我们知道说有一些新鲜的水果啦或者新鲜的这种作物它在配送的过程当中如果温湿度没有控制好的话对这个作物的品质影响也是很大的所以透过这个冷链的这种运输我们在这个运输的车上也设计了这个卫星定位，就是 GPS 路线追踪，然后温度湿度的这个感应器，然后透过 NB-IoT把这个数据，就是车子一边在跑，我们这个数据就一边透过 NB-IoT把这个数据，就是车子一边在跑，我们这个数据就一边在送到云端器，然后记录在区块链里头所以我们扫这个 QR code 就可以做非常非常的完整的这个信赖的溯源然后还包含说，因为这个农场是有机的农场，所以它的有机的这个证明就是证书啦或者其他如果非有机的可能就是农药残留的检验报告或者这个生产履历等等它的整个田间记录都是用区块链把它保存那因此是可以我们讲完全可以信赖这种溯源的这个功能好，那最后就是介绍一下说目前因为台湾的农业面临两大这个痛处啦，一个就是缺人工一个就是年纪比较老化，也就是说非常有经验的农民几十年30、40、50年年纪很大他没有办法再等于说去负荷传统的这种农务所需要的体力所以因此就是说传统的农业非常需要这种ICT 的这个科技来帮忙。那我们知道说当然 ICT 的科技有很多的可以用在农业上，包含说 IoT刚刚提到温度、湿度、电导度氮磷钾酸碱值然后微气象站等等那甚至 robotic 就是我们讲一些机器手背机器人自动车啦这个在农场里面其实也都非常好。比如如果很多靠人工才可以做的事情，慢慢的如果有一些robotics来完成的话，比如抒花蔬果然后授粉采果如果可以有我们讲不管是机器手背或者机器车然后上面带着这个机器手背都可以那更多的像自动化都可以增加这个农作物的品质跟它的这个质量等于说质量都可以提升。那农作物采收之后过去20-30年来台湾大部分都还是靠重量做分级，也就是我在做这个我们叫做 grading 或者是 classification 等于做分级分类的时候呢，基本上都是靠重量。那我觉得machine learning 这个或者 deep learning 本身这些技术影像辨识可以对这个作物分级可以帮很大的忙就不只是重量，而是靠影像。那影像本身又有靠外观的影像这一般的 video， 那或者靠内部的比如说用高光谱仪或者多光谱仪可以照到它这个作物水果它的内部的比如说含水量或者它的甜度或者酸甜比那我觉得把这个等于说 AI machine learning 的这种技术用在 作物分级分类哈，那对农民也是有很大的帮助，因为我们知道说这个分级分得好，它的价格有时候差了好几倍。好，那当然再来就是说这个台湾的农民哈，就是说有些是很会种可是呢他没有通路了就是说他有很好的产品，可是他不会卖所以怎么样帮他建立这个我们讲行销的通路那尽量避免中间商的这种剥削应该也是一个很重要的事情，就是产销平衡我们知道说台湾很多农作物呢都是产销失衡就是说在某些季节就会很多水果像香蕉啦、凤梨啦、高丽菜啦这个大家都知道每年在特定的时间我们叫做崩盘就是价格会非常非常的不好。那怎么样去建立这个产销平衡这个是非常重要。那透过区块链信赖溯源那我们可以把这个等于说优质的农产品提供给消费者让消费者因为有更高的可靠更高的信赖嘛所以应该就有机会愿意花多一点钱或者说愿意买这样可信赖溯源的这个农产品那所以刚刚提到这个区块链的技术它就可以来保证我们这个食材啦不管是刚刚讲水果啦、蔬菜啦甚至鱼货就是鱼虾这些蟹等等那这个安全就是食品安全那这样也可以增加这个农民的这个营收了那未来的挑战包含说因为现在在土地的这种我们叫微量元素的这个感测上还是相对的没有那么成熟，所以很多这个土壤里面微量元素都还是要把土壤采集之后要送那个实验室去做这个化验，那这个当然成本贵，然后时间很长如果未来有机会开发一些基于这个 AI 的这种晶片，然后可以量测土壤里面的微量元素那当然氮磷钾是最重要的，因为这个是等于说土地的肥力嘛当然还有其他像钙镁这些特别微量的元素可能对一些作物非常非常重要的那如果可以有这种 AI 晶片的开发我觉得对农业的升级是非常非常重要的好，那最后就是说AI 的做 Edge Computing像刚刚提到说如果我们有一个智慧眼镜那它戴着这个智慧眼镜我们在做蔬花蔬果修枝就是说做很多农作物的作业的时候呢那透过这个智慧眼镜它可以告诉我们应该怎么做也就是说把那个经验农民的经验透过智慧眼镜那当然因为智慧眼镜要有 AR 的技术嘛，因为才告诉我们说哪些刚刚讲花苞要留下来，哪一些果要把它疏掉，哪些叶子要修剪等等要透过 AR 来指示那可是通讯呢可能将来要透过 5G 因为要高频宽低延迟当然这个智慧眼镜上面会有一个 GPU 相当于要很小的这个processor 嘛所以如果有像这种可以做 Edge Computing 的设备像智慧眼镜或者其他的我觉得对这个农作物的这个农场管理都是非常非常重要。Okay, that's my presentation and also thank you for your attentions. Bye bye.
you are going to hear a presentation from Professor Chongwei Cai. Professor Cai is currently an assistant professor of National Sam Yat-sen University, Kaohsiung, Taiwan. His research interests include computational intelligence, data mining, cloud computing, and the Internet of Things. Today, he's going to give us a presentation entitled An Effective Hyperparameter Optimization Algorithm for DNN to Predict the Number of Passengers at a Metro Station. Ladies and gentlemen, let's welcome Professor Cai.
Good afternoon, everyone. This is Chongwei Cai from National Sam Yat-sen University, located in the harbor city in southern Taiwan, Kaohsiung. We do have a beautiful landscape. If you happen to be in Taiwan one day, please don't forget to give it a visit, and it will definitely give you a very good memory. First, I would like to thank Professor Chen for inviting me to give this talk. The research I'm going to talk about today is entitled An Effective Hyperparameter Optimization Algorithm for DNN to Predict the Number of Passengers at the metro station. Different from all my previous talks, they are focused on IoT device or IoT-driven technologies. This talk is on how to find out useful information that is hidden in the data collected by the IoT device. In my opinion, this can be regarded as an application of IoT that provides an alternative way to add value to an IoT application. Of course, this study is done by some of my students and myself. It's about how to apply deep learning technologies to precisely predict the number of passengers in a metro station of the metro system in Taiwan. And most important goal is to find out a set of suitable hyperparameters of DNN. Here's the outline of this presentation. I will start with the motivation of this research and a few relevant works. Then I will talk about the proper differentiation of hyperparameter optimization and the details of the proposed methods. Here, the discussion will include two hyperparameter optimization methods. One is for passengers prediction on a bus, while the other is for the passengers prediction on a metro station. Both of them have been published. If you are interested, you can also find out the papers on the internet. Finally, it comes to the conclusion. Since this talk is online, if you have any question, please feel free to send an email. I will be happy to answer your question. Now, let's turn to the motivation of this research. In Taiwan, we do have two main metro systems. One is in Taipei City and the other is in Kaohsiung City. Here, I just want to emphasize that metro systems in Taiwan are typically pretty busy and crowded, especially in rush hours. According to the data provided by Taipei government, in rush hours, the number of passengers entering and leaving the Taipei station can be up to 40,000 per hour. That's why we need a lot of turnstiles in such a station. Today, these turnstiles can help us collect the data of customers, such as when a customer enters a metro station and when she or he leaves another station. From the data, we can find out some unusual behavior, such as a customer enters and leaves the same station. The reason may be different. Either way, these data are now open to the public on the internet. Later, everyone can download them from the website of Taipei government. Of course, the user ID and anything that is personal have been removed from the data because privacy is a major concern. With this data at hand, now the question that arises is, how do we predict the number of passengers in a metro station? This has been a promising research topic because a precise prediction will be useful for planning ahead the route and for the management of the metro system to provide convenient service to the metro passengers. More important, this information will also be very useful for the government to predict the number of passengers at the metro station on a particular day to further make plans for the quality control. Yes, we can see that many studies have attempted to present useful way to predict the number of passengers in a metro station. All of them are statistical analysis, data mining, machine learning, and deep learning. Here, machine learning replaces traditional learning technologies such as support vector machine or random forest, while deep learning replaces the deep neural network-based algorithms. According to our observation and some previous studies, hyperparameters will strongly impact the end result of machine learning and the deep learning algorithms. The hyperparameters usually can be regarded as a set of parameters such as the number of hidden layers, the number of neurons in each hidden layer, and even the learning rate. This is due to the fact that most of them typically have many parameters, but do not have a good way to set their values, especially for deep learning-based algorithms. This means that when a researcher wants to use a deep learning algorithm for solving a new optimization problem, sure, he may need to fine-tune these parameters manually by using terminology and or try and error, ask some expert or Google it. Without a good setting of these parameters, the end result of DLM-based algorithms may be worse than traditional machine learning algorithms. That's why how to find out a set of suitable hyperparameters for a deep learning have been a critical research issue. Before we talk about the proposed method here, I will first give some examples to let you have some background about supervised and unsupervised learning algorithm. Then I will talk about the technology of neural network, deep learning, and the meta-heuristic algorithm that will be used in this study. The first example is to explain that the concept of supervised learning. Now let's go to the first step, and suppose they are a input object. Because it is a supervised learning, all these A input objects are labeled by the user or expert before they are used as input to the supervised learning algorithm. Here, I have to emphasize that these input data objects are typically called training data sometimes. I mention this because you will see the testing data later. As you can see in the example at step 2, this labeled data or object will be then fed to the supervised learning algorithm. Because the supervised learning algorithm now has the information about to which groups the input object belong, it will now be responsible for finding out some hyperlines that can classify these input objects. So these hyperlines can be called classifier. Of course, we can use the other way to classify the input objects, such as rule. Okay, now we do have some hyperlines that can help us discriminate input objects into different groups. Thus, in step 3, when we have new input objects we have never seen. These hyperlines can be used to help us decide to which groups these unseen input objects belong. Of course, these unseen input objects are typically called testing data. This process is also called data classification in data mining research domain. Also, because the training input object play the role of helping supervised learning algorithm construct the classifier, it's just like we use some knowledge, I mean the label of objects to teach a supervised learning algorithm how to classify the data so that it can then handle the classification job of unseen objects. That's why this kind of method is called the supervised learning algorithm. So in this example, it can be easily seen to which groups these two unseen objects will belong. As you can see that the example in this slide is used for an unsupervised learning algorithm. Different from a supervised learning algorithm, the best idea of an unsupervised learning algorithm is in that it will attempt to figure out ways to classify the unseen objects by itself. This means that all the input objects are not labeled, so most unsupervised learning algorithms have to learn how to do its job by itself. Although the accuracy of most unsupervised learning algorithms may be worse than that of most supervised learning algorithms, it provides us a way to let a computer system learn by itself when only have unseen data. I personally believe that it may be one of the future of AI. Here is a simple example of neural network. On the left-hand side is the input layer of this neural network, while on the right-hand side is the output layer. Between the input and the output layers are the so-called hidden layers. The arc between nodes in this slide are the weights. The best idea of neural network is to fine-tune the weights by many input data and their feedbacks. In this example, we will use neural network to classify two calculator, L and M. Assume each calculator is divided into 4 blocks before they are entered to the input layer. As you can see, the right top block of the L calculator is empty. Thus, a 0 is input to its associated input node. In contrast, the other block of L are not empty. As such, a 1 will be input to their associated input nodes. The M calculator can be input to this neural network similarly. Yes, you can imagine that all the blocks of the M calculator are not empty. Therefore, all of them will get a 1 to the node of the input layer. After a certain number of iterations, typically we call the A part in this domain. This neural network will be based on the classification result of the upper layer to fine-tune its weight. This means that some of the weight between nodes will be emphasized and all of the weight will be fine-tuned so that the data can be classified into the right group or value. That's why we call it a model. In this example, you may see that some weights from the second node of the input layer are marked and emphasized, which may be useful to help this neural network distinguish L and M. Of course, some of our studies have already pointed out that the end result of a neural network can be improved by increasing the number of hidden layers. However, in many very expensive computer or take a lot of computation time. That's why not many researchers focus on this research topic in early studies. This slide gives a simple example to show that deep neural networks. As you can see, a main difference between neural network and deep neural network is that deep neural network has many more hidden layers. Of course, from 2010, we can see that a lot of different deep neural networks have been presented. All of them provide successful results for us. Now let us turn our discussion to the best idea of meta-user algorithms, which can be regarded as an unsupervised learning. Before we process, I must remind you that the so-called meta-user algorithm is not a single algorithm. Rather, it represents a set of search algorithms. They use a set of guesses to find out a good solution in the solution space. In other words, the meta-user algorithm can provide an alternative way to find out an approximate solution in reasonable time in solving complex optimization problems. Here is a simple example to show that the best idea of meta-user algorithm. Every player of this game has to decide 4 secret numbers, all of which must be different. Yes, you perhaps played this game before. In this game, you have to guess the 4 secret numbers of your friend. So, you will try to guess 4 numbers at the very first. Now, without any hint, you can start with 1, 2, 3, 4. Then your friend may give you a response. If the secret number are 9305, then the response from your friend will be 0A1B. Here, the number with A represents how many numbers are not only right but also in the right position. Of course, the number with B represents how many numbers are right but in the wrong positions. This response provides some information to make a better decision in next case. So, from this example, we can divide the decision process into 3 steps. They are guess, feedback, and deduction. What these 3 steps do is just like what the 3 operators of a meta-user algorithm does in solving an optimization problem. They are transition, evaluation, and determination, which play the rules of generating a new candidate solution, evaluating the new candidate solution, and making a decision on the region in the solution space to search and later iteration. Before we talk about the proposed methods, I will first give a simple example to explain the definition of this problem. In the training step, you may consider that the goal of this problem is to find a good model, say M subscript lambda, that minimize the value of the loss function. Of course, we all know that the end result will be strongly affected by the learning algorithm, but we can try to use different hyperparameters for this learning algorithm to further improve the end result. Then, in the testing step, you will feed unseen data to the trained model to to get the value of the objective function. This result represents how good these hyperparameters are for the learning algorithm. Okay, here is a more precise problem statement to show how we measure the end results of the proposed algorithm. First, a data set D is given and is divided into a training set D superscript T and a testing set D superscript V. In this problem, we do have a search algorithm and a learning algorithm, which are denoted by different A symbols. Here, of course, the search algorithm plays the role of finding a set of good hyperparameters, while the learning algorithm plays the role of constructing the classification model. Also, we do have a loss function and objective function. The ultimate goal is to use the search algorithm to find a set of hyperparameters lambda for the learning algorithm A. I mean, it will denote by A subscript lambda, which will use to minimize not only the value of the loss function for the model M subscript lambda, but also the value of the objective function. Equation 1 will be used to calculate the minimal value of the loss function for a set of hyperparameters found by one run of the simulations. F superscript star replaces the objective value of the base model, and F bar replaces the average value of all the models found by n runs of the given search algorithm and the learning algorithm. Now let's combine the contents of the previous two slides. Then we can get this integrated view of what we do in this study. In fact, you may see that we just try to put a search algorithm in the classification system to find out a set of good hyperparameters for the learning algorithm in question to further improve the end result of the classification system. This slide gives a simple example to illustrate the impact of the hyperparameters on the performance of a learning algorithm. Yes, as you can see, suppose that the solution space is two-dimensional, each of which represents a hyperparameter. Further, suppose that each blue circle represents the possible value of hyperparameters x and y. Although we can put this test of hyperparameters for different positions in the y coordinate and the same position in the x coordinate, this line text may end up with similar result because y is not an important hyperparameter. This means that the value of hyperparameter y is pretty minor, not like the value of the hyperparameter x. Moreover, we typically don't know which hyperparameters are important and which are not. From this observation, for such an algorithm, how to find out a set of good hyperparameters then can be regarded as an optimization problem. These two examples have been discussed in the first reference as shown at the bottom of this slide. The example on the left-hand side shows a typical approach called GUI search, which will put all the text evenly distributed in each dimension. In this example, there are 9 spots evenly distributed in the solution space, implying that g of x will evaluate only 3 distinct values of x, which represents 3 values of hyperparameter x, and only three distinct values of y, which represents three values of hyperparameter y, so that we get 9 combinations of x and y. However, it may just lack takes 3 possible hyperparameter sets. The example on the right hand side shows that if you let all the spots, all the text for the hyperparameters randomly distribute in the solution space, it may be able to take 9 distinct hyperparameter sets, which means that you will eventually check more possible solutions than grid search. Alright, now let's move on to another 2 examples, which are heuristic algorithm and meta-heuristic algorithm. The example on the left-hand side represents the best idea of heuristic algorithm that each search. Here we also use the blue circle to represent each search. Move to the position that may get better result. However, because the design of most heuristic algorithms considers only how to move toward good position, the search may fail into a local optima. The example on the right hand side shows that the best idea of meta-heuristic algorithm. It means that the design of most meta-heuristic algorithm will be able to escape the local optima if it is not too deep or not too high. This is the reason why we use meta-heuristic algorithm for hyperparameter optimization problem of deep learning in this study. Next example further shows that most meta-heuristic algorithms have their own mechanisms to escape the local optima. However, after a certain number of iterations, most of the searches will also change to a particular region because the searched solution in that region are much better than others. Here I would like to start with a simple example to explain that how to apply a meta-heuristic algorithm to the hyperparameter optimization problem of deep learning. As you can see, this example is a combination of similarity annealing, here we call accelerator, and deep neural network. In this example, XA is used to find out a set of suitable values for the number of neurons in each hidden layer. So you can see that after neighbor selection of SA, you will generate a set of possible values that can be used to control the number of neurons for different hidden layers of DNA. In the middle of this line, you can see that this method will use the hyperparameter settings created by SA to further control the DNA. Yes, if we can find better results, then SA will continue to search the other possible hyperparameters based on this solution. Since it is an early study of ours in this domain, we use it to prove the concept of this approach. So it is very simple but useful for deep learning. This slide shows that we attempt to use the method presented in the next slide to predict the number of bus passengers on a bus for a stop of a particular route during a specified period of the time. The data comes from Taichung City Smart Transportation Big Data Research Center of Taiwan. In this simulation, we use 5 routes of bus to measure the performance of the proposed method. The proposed algorithm is shown in this table. It's called SADNN. This table shows that the proposed algorithm can find better results than other algorithms in terms of IMSE. After that, what we want to know is, can we use better meta-Hughes algorithm to find suitable hyperparameter of DNN to further improve its end results? As we mentioned before, most meta-Hughes algorithms may still fail into local optima after a certain number of iterations. For this reason, we derived an effective meta-Hughes algorithm based on the so-called investment of economics to avoid the searches of a meta-Hughes algorithm from easily failing into a local optima during the conversion process. So let's first assume that this new meta-Hughes algorithm will search for A solutions in the solution space at the iteration T. Let's further assume that this algorithm will divide the solution space into 4 regions. After iteration T, some of the regions give better solutions than other regions in terms of the objective value or fitness value. Because the solution in regions are subscript 1 and subscript 2 are better than the other solutions. The meta-Hughes algorithm we present in this study will adjust the other 4 searches so that they will move toward to regions are subscript 1 and subscript 2 at the next iteration. The figure on the right hand side shows that some of the searches in regions are subscript 2 and subscript 4 might move toward region subscript 3. It is not because the solution in regions subscript 3 are much better than the others. I mean, it's just because the region subscript 3 does not have any solutions after iteration T+1. This is one of the reasons if a region has not been searched for a long time, the search algorithm may only focus on other regions which may fail into local regions. That's why we increase the expected value of this region. Then the searches will move to such a region to prevent the proposed method from easily failing into a local optima. So compared with the other existing meta-Hughes algorithms, the distinguishing feature of SE, the proposed algorithm, in that it will first divide the solution space into a set of regions. Then you will use the expected value of each region to evaluate the potential of a region. And finally, you will move the circular toward high potential region. As we mentioned before, in the proposed algorithm, the SE, the expected value of a region will be used to replace the objective value or fitness value to evaluate the candidate solutions. You can see that the expected value E subscript ij contains 3 parts, where f represents the normalization function. T subscript j represents the ratio of how long this region have been invested to how long this region have not been invested. If this region have been searched for a long time, this value of T subscript j will be getting smaller. Otherwise, if this region have not been searched for a long time, the value of T subscript j will be getting larger. B subscript I superscript j represents the potential of the new candidate solutions created by the circular I in the J region. The last part is M subscript J, which represents how good the current solution in the J region is compared with those in the other regions. This equation shows that the proposed algorithm considers not only the objective value or fitness value, of the search solutions to determine the later search duration. It also takes into account how long the region have been searched, the possibility of the new candidate solution, and the current solution at the same time to determine the search durations. This slide gives a simple example to show how the passengers' data are entered into the DNN and how MAP is used to measure the result. Of course, there's nothing special because it's just like other DNN applications you may find on the internet. This slide gives another simple example to illustrate how search economics is used to find a set of good hyperparameters for DNN. In this example, the resource arrangement operator of SE we call RA later will first divide the solution space into two regions, each of which has its own searcher. In the region search operator, we will call it VS. Each searcher will recombine all samples nodes in these two regions to create some new candidate solutions, all of which represent different sets of hyperparameter settings. Then SE will calculate the expected value to let some searches of SE chain to this region to avoid the searches of SE from failing on particular region at the later stage of the conversion process. The data used in this study is collected by Taipei Metro over 2.6 million records from July 1, 2017 to December 31, 2019. Since the data size is too large and it requires a lot of time to train the DNN model, we have done some pre-processing to clean up and reduce the data. You can see that after this pre-processing processes, the total training data was cut down to 17,520, while the testing data was cut down to 8,760. The size makes more sense for us to train the DNN model to predict the number of passengers in a metro station in a reasonable time. Moreover, in this study, we also use other three kinds of the data set that are the data of rainfall, installation duration, and the temperature in Taipei City in the late time period. To evaluate the performance of the proposed algorithm, SE-HPO, also called the DNN with SE in this study. For solving the HPO problem, we compare it with 7 algorithms. The first 3 of them are the traditional machine learning algorithms, while the next 4 of them are the DNN-based algorithms. The next 3 are DNN with 3 different hyperparameter search algorithms. Here is the information about the simulation environment. We use many RTX GPUs to train the prediction models. These two figures show that the convergence chain of the 4 DNN-based algorithms for the training of weekday prediction model and the weekend prediction model. The results show that a better hyperparameter setting for the DNN will be able to improve its performance in the training process by using an effective meta-hit algorithm like the search economics. These two figures provide a detailed view of the show periods of weekdays and the weekends of the July 2009. It can be easily seen from these two figures that most of petition results of the proposed argument are close to the ground truth. For example, as shown in the figure on the left-hand side, at 5 o'clock p.m., I mean the 17 in the X correlated, the proposed argument is much closer to the ground truth than all the other DNN-based arguments. The same situation can also be found at 6 o'clock in the same figure. This table gives a detailed result of petition arguments in predicting the number of passengers of Taipei main station for different months of 2019 in weekday. This table gives a detailed comparison result of different petition arguments over the weekend of 2019. It can easily see that the traditional arguments such as the random forest argument can provide a better result than SVR and even DN on average. The result of SEHPO shows that good setting of the hyperparameters is able to improve the accuracy of prediction for the DNN. Finally, here are the conclusions and the future works. In this study, we present an improved version of SE for hyperparameter selection to predict the number of passengers of a metro station. It explains that the meta-Hughes algorithm is able to improve the accuracy of DNN by using it to fine-tune the hyperparameters. This also implies that the meta-Hughes algorithm may end up being an important part of AutoML. In the future, we will devise an efficient way to enhance the performance of DNN-based algorithm. As shown in the slide, we just list some possible research directions such as visualization, new network architecture, preprocessing, and find out some useful domain knowledge. Okay, this is all my talk today. Alright, thank you very much for listening. If you have any question, you are welcome to send me an email to discuss the relevant research of this talk. Thank you very much again.